What three parts does the brainstem consist of? A. Pons, cerebellum, medulla. B. Corpus callosum, medulla, and cerebellum. C. Medulla, pons, and midbrain. D. Midbrain, cerebellum, pons. The answer is C. Medulla, pons, and midbrain. The brainstem consists of the medulla, the pons, and the midbrain. The cerebellum is an outgrowth posterior to the pons. The corpus callosum is the broad bundle of neural fibers that attaches the left hemisphere of the brain to the right hemisphere. Olfaction is what form of sensory reception? A. Chemoreception. B. Thermoreception. C. Mechanoreception. D. Baroreception. The answer is A. Chemoreception. Olfaction is form of chemoreception, or a translation of a chemical signal into an action potential. Smells are triggered by molecules of volatile chemicals that trigger chemoreceptors in the epithelium of the olfactory cleft. Olfactory nerves travel through what structure in order to enter the skull? A. The cristagalli. B. The cribriform plate. C. The ethmoidal labyrinth. D. The perpendicular plate of the ethmoid. The answer is B. The cribriform plate. The olfactory nerves travel through the cribriform plate of the ethmoid bone. The grooves of the cribriform plate support the olfactory bulb, and the bone is perforated by many tiny foramen for transmission of the olfactory nerves from the epithelium of the nasal cavity to the olfactory bulb. The other structures listed are all bony features of the ethmoid bone, but they do not allow the passage of olfactory nerves. Approximately how many action potentials must be triggered in an olfactory receptor neuron in order for a smell to be detected? A. 40 to 50. B. 1. C. 200 to 250. D. 80 to 100. E. 2 to 5. The answer is A. 40 to 50. Olfactory receptor neurons require 7 to 8 molecules of a volatile odorant to trigger an action potential, and approximately 40 action potentials must be triggered in an olfactory receptor neuron in order for a smell to be detected. What type of cell is embedded in the olfactory epithelium? A. Olfactory sensory neurons. B. Supporting cells. C. Basal cells. D. All of these. The answer is D. all of these. There are three types of cells embedded in the olfactory epithelium: basal cells, supporting cells, and olfactory sensory neurons. All three of these cells play a significant role in the sense of smell, though the olfactory sensory neurons are the only cell type that actually respond to chemical stimuli.